So this time around we're going to be talking about covalent compounds and covalent bonds. A covalent bond is formed by sharing of electrons. Formed by sharing electrons. And we'll be able to draw this in a little bit, maybe give you a better visual, but instead of it, you remember like sodium chloride would be an ionic bond. Instead of an electron going from sodium that has an extra electron to chlorine who wants an electron, covalent bonds are kind of playing tug of war with the electron, or imagine it kind of like a Venn diagram. We've got a Venn diagram and you've got two circles. They're sharing the electrons that are in the middle. And the elemental composition, don't let that confuse you or scare you. Elemental composition is just saying, what are these bonds made of? What elements make these things up? And last time we said the ionic bonds were metals and nonmetals. This time, for covalent bonds, its elemental composition are two nonmetals. So you could say a nonmetal and a nonmetal, or you could write two nonmetals. Either one is fine. The boiling point. So boiling point and melting point are obviously not the same. We've talked about heating and cooling curves. We've talked about what the boiling point is and what the melting point is. But for covalent compounds, whatever the numbers are on these numbers are going to be much, much lower than ionic bonds. Ionic bonds like sodium chloride are going to be, those are ionic. They're going to be very, very strong bonds, and their boiling point and melting point are very high. Compared to covalent bonds, think of sugar. You can melt sugar with a candle, and that's because its melting point is very low. And so covalent compounds have a very low boiling point and melting point. So it's low because it doesn't take a lot of energy to break it. Remember, when there's a bond, or just atoms in general, they're always moving, and when it's in a lower state of matter like a solid, a slower state of matter like a solid, they're just kind of jiggling, they're just moving back and forth, vibrating. But the more you increase the temperature, the faster those are moving, and eventually it gets to a point where the structure that's holding it together cannot hold anymore, and it breaks off. And then, from a solid it would go to a liquid, and the same thing happens with a liquid. If you excite them enough, if you make them move fast enough, they'll actually break out of that liquid and they'll turn into a gas. And because these bonds are formed by sharing electrons, because they're covalent bonds, they're very weak. They don't hold a whole lot, it requires very little energy for the structure of it to break. And conductivity, this one should make sense as well. It's not conductive because, again, we're dealing with two nonmetals. Metals are very conductive for electricity and heat, but nonmetals are not, so they're not very conductive. All right, so now we're going to get into rules. There's some rules for naming covalent compounds. I'm going to go ahead and I'll write each one, and then I'll talk about it. All right, so I went ahead and wrote all of them. Let's go through them. Prefixes. So these prefixes that are found on the other side over here, we'll get to that in a second, but these are the prefixes. These prefixes show how many of each element there are present, and you can find them over there. We'll talk about those in a second, but examples of these would be mono, di, tri, hexa, octa. So you're familiar with things like carbon monoxide. That would be, mono would be a prefix. It tells you how many there are, and we'll get to that. I think these will make a lot more sense once we start going. The second element, remember there's two, these are binary compounds, so the second element is going to end with IDE, and we've seen that as well. So you can think, again, monoxide, carbon monoxide, the IDE, or if it's chlorine, it's going to be chloride, or bromine is bromide. You're going to add the last couple, you're going to take off the last couple letters, 2, 3, 4 letters, and then add IDE. And if you make a little mistake on that, it's not a big deal, but just know that it needs to end in IDE. The second element ends in IDE. And then these two you've pretty much done it. If you've done these two steps, adding prefixes to both, and the second element ends in IDE, the covalent compounds are pretty easy to name, but these two are kind of like specifics. They kind of make it, if you don't do these two, you'll still be able to identify it. You'll just look kind of funny in calling it that. It's like calling a tomato a tomato. You get the gist of it. It's just not exactly the right way. Sorry if you say tomato. Drop the vowel if it repeats. So for monooxide, we don't say monooxide. We say monoxide. So we drop, if there's a repeating vowel or sound there, we drop one of them. So again, if you wrote monooxide, you just look kind of funny. It's not actually, I'm not going to count it wrong, but just try to do that monoxide, write it the right way. And then the last one, don't write mono for the first element. So carbon monoxide, I keep using that example. Let me write it right here. Carbon monoxide, that's carbon monoxide. There's one carbon, there's one oxygen. And so we don't say monocarbon monoxide, monocarbon monoxide. We just say carbon monoxide. If it's just carbon, if it's just like normal, if it just says carbon, then we assume that there's only one there. And then the second one is what you have to do to say monoxide too. All right, before I go through these, see if you can go through and answer these on your own. See if you can fill in the blanks on these. Some of these I think you'll know, some of them you won't. I don't want you to stress about it. Just be interested to see. Obviously, we just talked about mono, so mono is pretty easy. But I'll go ahead and fill these in, and you can copy onto yours. But see if you can, as you're writing them, think about other examples where you've used these prefixes. All right, so mono is the first one. Mono is one. Di, sometimes people use bi like binary. We use bi, but for this, when we're naming these compounds, it's going to be di, di. Tri, which should be familiar, like triangle. Tetra. Penta, like pentagon, it's 5-sided. 6 is hexa. Hepta. Octa. Nona. Deca, like decade or octagon. So I'm going to go ahead and pause it and fill those in. We're going to work these through together. So carbon monoxide, we've already done that one. So there's one, we don't have to write mono here. That would be weird. So this is going to be CO, because there's one oxygen. And remember, you see that we have ides on these last words. Hexa, let's look up here. Hexa is 6. Let me back up. Let's do the B and O. In hexa, there's going to be 6. And oxygen, there's going to be 2. All right. Phosphorus trichloride, that's going to be a phosphorus. And then this is going to be a Cl because it's chloride. And then we look, there's no prefix for phosphorus, so there's just a 1 there. We can write, but it just looks kind of funny if you do that. And then trichloride is 3. So we've got carbon monoxide, hexobromide is a Br, sorry, Br6O2. Phosphorus trichloride. And then this is nitrogen, so I'll go ahead and write nitrogen. Change colors. Got nitrogen. And then there's going to be an oxygen. So I know that's going to be an oxide. You can see I've left a big space here in between so I can fill these in. So this is going to be, there's 2 of them, so it's going to be dinitrogen. I would normally write these words together, but I'm trying to show you that they're prefix and suffix. Dinitrogen monoxide. So the way you would write this would be monoxide, and dinitrogen, not the di would be closer. Dinitrogen monoxide. Okay, go ahead and pause it and see if you can do the other 2. All right, hopefully you've had a second to pause that and look at it. So on this one, we would do carbon tetrachloride. This would be this one, carbon tetrachloride. There's one carbon, monocarbon, but you don't say mono. And then tetra, because there's 4. And then same thing, oxygen. There's no mono before it because it's the first word. So oxygen difluoride. So we'll have some more of these to practice, but that's the gist of it. And if you understand this, then you're good to go.